So let's continue with example 3. So in this case, we're going to talk about coterminal angles. In some situations, the exact degree measure of the angle is not important, and we just want to know where it lies within the unit circle. So in this situation, a coterminal angle is an angle that potentially goes around the circle more than once and terminates somewhere. And so we can measure that angle more simply by just figuring out where the terminal side is and measuring just once instead of including all the times we went around a complete circle. So a coterminal angle is always going to be different from the angle given by some factor of 360 degrees, since 360 would be the full circle, so you can see that identified there like that. So for the first example, it says identify all the angles that are coterminal with 45 degrees. We obviously can't write them all out because there's an infinite number, so we'll have to express it like this: 45 degrees plus 360 degrees times k. And that'll give us every possible coterminal angle. If we want two examples of coterminal angles, we could do 45 degrees plus 360, or we could do 45 degrees minus 360. And so this is going to be 405 degrees, and then negative 315 degrees. And both of those angles, 405 and negative 315, are going to lie right here. Alright, so why don't you guys try section B of this example, and then you can check back in the notes in just a second and see what the answer is. Okay, so let's do the opposite of what we just did. We have an angle that is larger than 360 degrees, and we want to find a coterminal angle that's between 0 and 360 degrees. So in this case, there's two different methods that we could do. One method would be for us to understand that every time it goes around in a complete circle, it's 360 degrees. So we could take the original value and subtract 360 until we get a number that is between 0 and 360. So we subtracted it once and we got 415. So we subtract again and we'll get 55 degrees. So it looks like a coterminal angle here is going to be 55 degrees. And all we did was subtract out each of those complete revolutions. Another way that we could have solved this problem is to take 75 and divide by 360. And again, that number 2 there represents there were 2 complete revolutions, just like we found in the previous method where we had to subtract twice. What's left over, that decimal, is the portion that our coterminal angle is. So when we multiply that, we get 55 as well. So one way that we did it was 775 minus 360, and that gave us 415. That was still bigger than 360, so we minused 360 again, and that gave us 55 degrees as our coterminal angle. So here we have negative 1,279. And we can do the same thing, but in this case we're going to be adding 360 to get that number between 0 and 360. So we'll just keep adding. Okay, so we have two options. We could leave it as a negative angle or we could leave it as a positive. So we could express this as, we found negative 217, or we could express it measured counterclockwise as a positive angle and gotten 143 degrees. So these two are actually also coterminal. And it depends on what you're doing whether or not you would want to express it with the positive or the negative. Let me give you guys an example to try on your own. So let's try 595 degrees and negative 777 degrees. Try those, pause the video, and then come back when you're done. Okay, for this last part we're going to talk about reference angles, which is another way that we might measure angles, especially in physics where we're constantly changing the way we measure an angle. We don't always measure with respect to the x-axis. We might measure with respect to something else because it's more convenient. So in this case, they tell us that a reference angle is the acute angle formed by the terminal side and the x-axis. So an acute angle is an angle that's less than 90 degrees. And the initial side of the angle does not matter. We're looking at the terminal side and the x-axis. So here we can see the terminal side and the x-axis. That's how we're measuring our reference angle. Now I'm not really interested in you guys remembering this this rule because all you really need to remember is that the degree measure in a straight line is 180 degrees. So if I measure an angle that's 135 degrees, then my reference angle is going to be 180 minus that, so it's going to be 45 degrees. And really that's all you need. If I have an angle that's below down here, so maybe I have something like this, and maybe that angle ends up being 100 and actually 225 degrees. Then all we need to do is say, well, the line is 180 degrees, so how much more than 180 degrees is this? And that would be, again, 45 degrees. That's what that chart up here is telling you. They're just telling you whether or not you should be subtracting 180 degrees or not. But it's easier to just figure out logically or geometrically by looking at the object. So let's look at 120 degrees. Now, the first thing we need to do is have an understanding of quadrants. This is quadrant 1. This is quadrant 2, this is quadrant 3, this is quadrant 4. Quadrant 1 ends at 90 degrees, starts at 0 degrees. This will be 180 degrees, so quadrant 2 is between 90 and 180. Quadrant 3 is between 180 and 270 degrees. And quadrant 4 is between 270 and 360, which is coterminal with 0. So 120 degrees is bigger than 90 but less than 180, so it's going to be in this quadrant. And it's 60 degrees short of being 180 degrees, so it looks like our reference angle is 60 degrees. For 135 degrees, 135 is again, or negative 135, sorry. We could convert that into a positive if we wanted, so we'd have negative 135 plus 360 to find the positive coterminal angle. And it looks like in that case we're going to have 2, 2, 5. So that's going to be bigger than 180 but less than 270, so it looks like that angle is in the third quadrant. And we just need to figure out, well, how much bigger is that than 180? And it's 45 degrees bigger than 180. Alright, so here's an example for you guys to try on your own. Pause the video, do it, and then come back and check your answer.